Hello everyone, I am Swarna Latha, working as an assistant professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the Gaussian random process and Poisson random process. So already in the previous lecture, we have seen the standard random variables like binomial random variable, Poisson random variable, and these two are discrete random variables, and remaining we have seen as uniform random variable, exponential random variable, Rayleigh random variable and Gaussian random variable, and these remaining four are continuous random variables. Now, the same random variable concept will apply to the random process also. So, what is the difference between random variable and random process? So, random variable is a function of the outcomes of the experiment. How do you represent the outcomes of the experiment? By S. What is small s represents the elements of the sample space, or this is also represents the outcomes of the experiment. So, if what is a random variable? A random variable is a function of the elements of the sample space, or it is a function of the outcomes of the experiment. Now, what is a random process? So, for this random variable, we are including a time function. Then it is called as what? Random process. So, there is a difference between random variable and random process. So, already in the previous lecture, we have finished the Poisson random variable and Gaussian random variable. Now, we extend the concept of this Poisson random variable and Gaussian random variable to the random process. So, first we'll see the Gaussian random process. So, what is a Gaussian random process? A random process x of t is said to be Gaussian process or Gaussian random process, or it is also called as a stochastic process, or it is also called as a normal process. If the set of the random variables defined in that random process is approaching a multivariate normal distribution, then it is called as what? Gaussian random process. So, what do you mean by the collection of the random variables? What does it mean? So, already we have seen the previous lecture. How do you define the random variables and the random process? So, what is a random variable? It is a function of only the sample space elements. It is not depending upon time. And the random process is a function of both the sample space elements as well as the time. Now, if in this random process, if I keep the time as constant, if I keep the time variable as constant, then this random process is varying only with respect to the outcomes of the experiment or the elements of the sample space. Here, what I am doing here, I am keeping the time as constant. It means it is not varying with respect to the change in time, because I have made this time as constant. So, it is varying only with respect to the S only. S is nothing but what? The elements of the sample space, that is also called as the outcomes of the experiment. So, if it is a function of only the outcomes of the experiment or the elements in the sample space, it is called as what? Random variable. So, therefore, I am taking a random process x of t. On this random process, I am defining random variables. I am defining n random variables on this random process. Now, with this set of these n random variables defined and the random process x of t are approaching the multivariate normal distribution. It means the joint distribution function of the Gaussian random variable. Then the particular random process x of t is said to be a Gaussian random process. And this Gaussian random process are very important if you take any application. So, many of the applications are modeled as a Gaussian process only. That's why this Gaussian random process is very important out of all the random process. And if samples of the random process, for example, I am defining n random variables. How do you define the random variables in the random process? By keeping the time as constant. If I keep the time t equals to t1, I am getting a random variable x1. If I keep the time t equals to t2, I am getting the random variable x2. Like that, by keeping the time as constant, I am defining what? N random variables on this random process x of t. Then, this random process x of t is said to be Gaussian random process if they form the jointly Gaussian distribution function. If they form the Gaussian n multivariate normal distribution, or it is also called as what? Joint distribution function of the n Gaussian random variables. then the random process is said to be Gaussian random process. And I told you that this Gaussian random process is important because any application, most of the applications can be modeled as a Gaussian process only. For example, I'm taking the COVID-19 case in India, second wave, first wave. So if I take this, so in the 30th January, we got only single case. After that, slowly it is increasing. It has reached a peak value. After reaching the peak value again, the cases are decreasing. If I draw the cases each day on the graph, then this graph is showing like a Gaussian. This graph is showing the Gaussian density distribution function. This is nothing but is a Gaussian distribution function. So, if I take this example, the COVID-19 in India, if I draw the number of cases versus and each day how many cases with respect to time. Here T indicates here time and here it indicates what? The number of cases in each day. If I draw the graph, it is approaching the Gaussian density function. So like that, if you take many real-time examples, almost all the cases are can be modeled as what? Gaussian random process. So what is a Gaussian density function? Already you have seen if x is a Gaussian random variable, if x is a Gaussian random variable, then what is the density function of the Gaussian random variable? Fx of x. So if you see here, it is the density function of a Gaussian random variable about the mean equals to 0. About the mean equals to 0. So at mean it is having the maximum value. As it is deviating the free mean, it deviate values is decreasing. So if I compare this with the COVID-19 cases in India, it is also approaching the Gaussian density function only. So from this, what can you analyze? You can analyze the parameters like what is the mean value, mean square value. You can calculate the distribution function, calculate the density function. You can calculate the probability and probability of the number of people, number of cases you may get. So if for 50 members or 100 members in each day, like that you can calculate, you can perform any statistical calculation by modeling this particular case as a Gaussian density function. Now I am taking a random process x of t, and this random process I am defining how many random variables? I am defining n random variables. How can I define the random variables? And the random process, this is a random process. So this is the random variables. How can I define? By keeping the timer as constant. If I keep a t equals t1, I am getting a random variable x1. If I give the time t equals to t2, I am denoting the random variable as x2. So like that, I am defining n random variables on this particular random process. Now this random process is said to be Gaussian random process if the joint probability density function, here PDF indicates probability density function. So now this Gaussian random process x of t is said to be Gaussian random process if the n random variables defined on this random process have the joint probability density function has been given by. So what is the density function here? Fx of, here x is indicates what? The random process x of t. So fx of, how many random variables you are defining? You are defining n random variables. X of t1 nothing but x1 and x of t2 is nothing but x2 and x of tn is nothing but xn. You are getting what? N random variables. So x1, where you are getting x1? By keeping the time at t equals to t1. Like that I am defining n random variables. So equals to what? 1 by square root of 2 pi power n mod of cx. Here cx is a matrix. It is not a value. It is a matrix, n by n matrix, into e power minus 1 by 2 of x minus x bar power t into cx inverse x minus x bar. So what is this joint density function? This is the joint density function of which? N Gaussian random variables. In the previous lecture we have seen the joint density function of n Gaussian random variables has been given by. The same case we are applying to the random process also, but the difference is here where you are getting these random variables, the particular time instance you have to mention here. Only that's the difference. And remaining everything is same. Now here what is n indicates? N indicates here the number of random variables defined on the random process x of t. So here what is n indicates the number of random variables defined on the random process x of t, and here Cx, it is a n by n matrix. So it is called as the covariance matrix. What do you call here? It is called as the covariance matrix. So what is a covariance matrix? Cx is equal to, it consists of number of rows are n and number of columns are n. So C11, C12 and so on C1n. So first row, first element, first row, second element, like that. And the second row is C21, C22 and so on C2n. And the nth row is Cn1, Cn2 and so on Cnn. So what is here? Cx is called as what? Covariance matrix, and the size of this matrix is, it consists of n number of rows, n number of columns. And what is Cxi xj? What is Cxi xj? Nothing but Cij. So what is Cij? It may be C11 or it may be C12 or it may be C1n or it may be Cnn. So Ij, what is I value? 1 to n, and what is the j value is also 1 to n. So it is the ijth element of this covariance matrix is equals to expectation of. So what if x and y are two random variables? What is the covariance of those two random variables? Nothing but expectation of x minus x bar into y minus y bar. And similarly here, it is a covariance matrix of the random process, and on this random process you are defining n random variables. What are the n random variables? X of t1, x of t2 and so on x of tn. Then how do you define this covariance matrix? How do you present the covariance matrix? It is called as what? Auto covariance, because in the same random process you are defining n random variables. Therefore it is called as what? Auto covariance. So Cxx of, and the first random variable I am getting by keeping the time at t equals to ti. And the second random variable I am getting that the time t equals to tj is equals to what? Expectation of here x minus x bar. How do you get the first random variable? At t equals to ti in the random process. So x bar is nothing but here x of ti bar into here what you are having? Y minus y bar. And how we are getting this here in the second random variable? X of, by keeping the time t equals tj in the random processes of x of t, you are getting the second random variable. So into, in place of y, you have to write down now x of tj. This is the second random variable. Here first random variable, second random variable. In case of the random process x of t, so this x of ti is the first random variable and x of tj is the second random variable. And the covariance between these two random variables like xy, here between x of ti and x of tj. So x of tj minus x of tj bar. So this is a covariance matrix. And what is the relation between the covariance and the correlation is given by what? In the previous lecture we have seen rxs minus x bar into y bar. And similarly here what is the relation between the covariance and the correlation? So rxs of, so in case of random process, you have to mention the time, at what time instance you have defined the random variables. You have to mention the times, nothing but ti and tj minus x of ti bar into x of tj bar. Now if I equals to j, so if I take this, here you are having C11, nothing but I equals to j, C22. So I value 2, j value is also 2. If take here c and n, I value is n, j value is also n. It means here in this case I equals to j. So in this case, what is the value of I and j? Both are constant here. Then if I equals to j, then what is the covariance matrix? Is equals to Cxs of, so ti minus ti, that equals to what? Expectation of x of ti minus x of ti bar into what? X of ti minus x of ti bar, nothing but x of ti bar whole square. Now what is this function? We know the variance formula. So what is the variance of a random variable x? Is equals to what? Expectation of x minus x bar whole square. So here in place of x, the random variable x, you have the random variable x of ti. Then it is nothing but what? the variance of, nothing but what? The variance of the random variable x at t equals to what? Ti. So nothing but sigma x square in place of x, I'm having what? X of ti. So it is a variance. So if I is not equals to j, so this is a ijth element. If I equals to j, this is ijth element in the covariance matrix. So now we have defined the variable n and we have defined the covariance matrix, and remaining what you have to define here? X minus x bar matrix. So here x minus x bar matrix is n by 1 matrix. N by 1 is nothing but consists of n number of rows and 1 column. So it's nothing but what? The first element is x of t1 minus x of t1 bar. Actually it should be what? x1 minus x1 bar, x2 minus x2 bar, and so on, xn minus xn bar. How do you get the first random variable? By x of t1. By keeping the time t equals to t1, you are getting the random variable x of t1, or x1 is also called as x1. And the second element is what? X of the second random variable is what? By keeping the time t equals to t2, nothing but the random variable x of t2 minus x of t2 bar. So this is the first row, second row, and what is the nth row? X of tn minus x of tn bar. And how many number of columns are there? Only 1 column. And how many number of rows are there? N rows are there. So therefore x minus x bar is a n by 1 matrix. And in this function what you are having? You are having x minus x bar transpose. What do you mean by transpose? Number of rows and columns should be interchanged. And what is the size of x minus x bar transpose matrix is 1 by n. And what is the matrix of Cx? Cx is a covariance matrix and it is the inverse of the covariance matrix. And this is a x minus x bar matrix. So this is a joint density function of n random variables, x of t1, x of t2, and so on, x of tn, defined in the random process x of t. So this is a joint density function. If it is having that joint density function, then the particular random process x of t is called as what? Gaussian random process. And let us go for the properties of the Gaussian random process. So for example, if a random process, Gaussian random process x of t is applied to a filter, linear filter, then the output of the filter is also again, it is a Gaussian only. For example, so this is my filter, linear filter, LTI filter, and the input applied to the filter is a Gaussian process. What is the input applied to this filter is a Gaussian random process. Then the output developed at this filter is called as, again it is also what? A Gaussian random process only. It means if the input is Gaussian, the output is also Gaussian only. That is the first property of the Gaussian random process. And the second property states that the Gaussian random process is completely defined the mean and the covariances of the matrix. So if you see here, the joint density function of the Gaussian random process x of t, where n random variables are defined and that random process, it is given by what this is. So here what is Cx indicates covariance matrix. So what is C11, C1, these are the covariance of the two random variables, and here x bar is nothing but what? The means of the random process. So it means if you observe the equation, the Gaussian random process joint density function is completely defined the mean and covariances of the random variables defined in the Gaussian random process. That is the second property. And the third property states that if a Gaussian random process is wide sense stationary random process, then you can say that the random process is also strict sense stationary random process. Now what is wide sense stationary random process and what is strict sense stationary random process? So what is strict sense stationary random process? If a random process is stationary to all the orders, then it is called as what? Strict sense stationary random process. It means all its statistical properties should not change with time. Then it is called as what? Strict sense stationary random process. And what is a wide sense stationary random process? The wide sense stationary random process is a subset of the strict sense stationary random process. It means here all the statistical properties should not change with time. Whereas if you go for wide sense stationary random process, only two conditions. What are the two conditions? The mean should be constant, should not vary with time. And second one is what? The autocorrelation function should not change with time. Then it is called as what? Wide sense stationary random process. Out of all these statistical properties, we are considering only two statistical properties. So the two statistical properties, the mean and autocorrelation. If these two are not varying with respect to time, then it can say that the random process is wide sense stationary random process. Now, if a random process x of t is wide sense stationary random process, then you can say that the random process is also strict sense stationary random process. Why? Because the joint density function of the Gaussian random process is completely defined through what? The covariance and the mean. And what is the relation between covariance and correlation we have seen? Cxx is equals to what? Rx of ti comma tj minus x of ti bar into x of tj. This is the relation between covariance and correlation, autocorrelation. Okay. Now, if it is not varying with the time and is also not varying with respect to time, then what is the covariance? And also not varying with time. It means the covariance is not varying with respect to change in time, as well as the means are also not varying with respect to time. It means the joint density function is not varying with respect to time. So it means the Gaussian random process, if it is wide sense stationary, then you can say that it is also strict sense stationary random process. And as it is defined only through the covariance, correlation and means only. That's why if it is wide sense stationary, then you can say that it is also strict sense stationary. And the next property of the Gaussian random process is the set of random variables x of t1, x of t2, and so on, x of tn are defined on the Gaussian random process x of t, which are uncorrelated. Then you can say that these n random variables are also statistically independent random variables. So these are the properties of the Gaussian random process. Next, coming to the Poisson random process. So already we have seen the Poisson random variable. So what is a Poisson random variable? So first of all, Poisson random variable is a discrete random variable. What do you mean a discrete random variable? If it is the values of the random variable are discrete in nature, then nothing but it is a discrete random variable. If the sample space is discrete elements, not continuous range of, if they are countable and finite, then you can say that the random variable is discrete random variable. When the elements of this random variable are countable and finite, then you can say that the particular random variable is a discrete random variable, and the Poisson random variable is a type of a discrete random variable. Now, and this Poisson random variable is used for what type of applications? Counting applications. The Poisson random variable is used for what type of applications? Counting applications. Now, the same concept of the Poisson random variable now we apply to the random process also. Now, what can you say that? Poisson random variable is a discrete random variable. Now, you can say that Poisson random variable process is a discrete random process. And it is used for what? Counting applications. And similarly, the Gaussian random process, the Poisson random process is also used to count the number of occurrences over the interval 0, t. Same thing here, applying the concept of Poisson, you are extending the concept of Poisson random variable to the Poisson random process only. Counting application is for the examples. For example, if you want to count the number of telephone calls occurs at a switchboard, or else if you want to count the number of customers are entering into the supermarket or a bank, or if you want to count the number of failure of equipment in a system, or if you want to count the number of electrons are emitted at the surface of the photodetector. So all these are the counting applications. You want to count the number of quantities within some time. Then you can go for what? Poisson random process. Now, what is the probability of the event? The random process x of t takes exactly k times. Is nothing but what? Lambda t power k1 into e power minus lambda t1 by k1 factorial. Here, this is ki And what is k equals to, it may be 0, 1, 2, 3 and so on. For example, if I want to count, for example, my random process x of t, I am defining a random process Poisson random process x of t, and let x of t is gives the number of telephone calls. For example, number of telephone calls coming at a switchboard, So this I am defining by a random process x of t. Now I want to calculate the probability of getting the number of calls exactly 50 in the time duration of 5 minutes. Let us say I want to count the number of telephone calls I am occurring in 5 minutes. Then how many number of calls I want to calculate? I want to calculate the probability of getting 50 telephone calls in 5 minutes of duration. Then how can I write the probability that P of x of t equals to 50 is equals to what? Lambda t power k. Here what is k? Nothing but 50 into e power minus lambda t by 50 factorial. Now what is lambda in t? What is t here? 5 minutes. And what is here? Lambda is called as what is average rate. For example, average rate is nothing but the number of calls getting occurs at an average rate of 100 calls. I am getting 100 calls for 10 minutes. For example, the average rate I am getting at the switchboard, particular switchboard is 100 calls for 10 minutes. I am getting. Then what is average rate here? 100. Then what is lambda here? 100. And what is t here? 5 minutes. So this what is lambda indicates here? The average rate. And what is t indicates? The time duration at the time interval. So this is the probability of getting exactly occurs k1 events in the time duration of 0 of t1 is equals to what? P of x of t equals to k1 is equals to what? Lambda t1 power k1 into e power minus lambda t1 by k1 factorial. So this is an example for this. Now I want to calculate the mean of the Poisson random process. So what is the mean of the random process? Mean is nothing but what? The expectation. So E of x of t. What is if x is a random variable, then what is the mean of the random variable? E of x, that can be represented by mu x. Similarly here mu x for the Poisson random process, in brackets I have to give t, because I can define the random variable in the random process by keeping the time as constant. If I keep t equals to t1, then I get the random variable x of t1 or x1. So like that I can take any value of t. Then what is the mean of the random process? E of x of t. That equals to what? What is E of x of the expectation of the random variable x? For example, here what type of random variable is a Poisson random variable? For Poisson random variable is a discrete random variable. For discrete random variable, how do you calculate the mean? Sigma xi into p of x equals to xi. And here similarly I want to occurs exactly k number of times. I have given here k number of times. So in place of x I will take here what? K. So k into p of x of t is equals to k. So what is p of x of t equals to k? So already have seen p of x of t equals to k1. So replace k by k1 by k. Then what is p of x of t equals to k here? Sigma k equals 0 to infinity k into p of x of t equals to k. Nothing but lambda to e power k by k factorial into e power minus lambda t. Where what is the k value? K value is from 0 to infinity. So that equals to, and here I can write on k factorial as k into k minus 1 factorial. Now here k will be get cancelled. Then what can you obtain here? Sigma k equals 0 to infinity lambda t power k by k minus 1 factorial. So where what is the value of k? K equals to 0 to infinity. Now in this, I can write lambda t power k minus 1 as, I can write lambda t power, here lambda t power k as, I can write lambda t power k as lambda t power k minus 1 into lambda t power 1. So k minus 1 plus 1, nothing but here get k only. So I can write lambda t power k as lambda t into lambda t power k minus 1. So bring this lambda t to the outside. So bring this lambda t to the outside of the summation, because the summation is depending upon k. So this is not a function of k. So you can bring this term to the outside. So lambda t into e power minus lambda t. In this source you don't have any k term. So bring it outside. Sigma k equals to 1 to infinity. You should not write here 0, because if I write 0, then I'm getting minus 1 factor. It is not possible. Therefore, write down k value from 1. So k equals to 1 to infinity lambda t power k minus 1 by k minus 1 factorial. Now, what is this sigma k equals to 1 to infinity? A power n. Nothing but what? Nothing but 1 plus x by 1 factorial plus x square by 2 factorial plus and so on x power n by n factorial. And similarly here 1 plus x square by 2 factorial plus and so on. This is a function of what? It's nothing but what? E power lambda t. What is e power x? 1 plus x by 1 factorial plus x square by 2 factorial plus and so on. How do you get this? By expanding. See, for example, if k equals to 1, so lambda t power 1 minus 1 by 1 minus 1 factor, nothing but 1. Plus if k equals to 2, lambda t power 2 minus 1 by 2 minus 1 factorial means this term we are going to get this term. So like that you have to substitute the k value and you have to expand the summation. You are getting this. And this is like 1 plus x square by 2 factorial plus and so on input, then nothing but e power x. In place of x I have here lambda t. Therefore lambda t into e power minus lambda into e power minus lambda t. So what is the mean of the Poisson random process is nothing but what? Lambda into t. Next, if I want to calculate the variance. So if x is a random variable, then what is the variance of the random variable? E of x minus x bar whole square. So if you simplify this, what can you write down this as? E of x square minus x bar square. What is x bar? Nothing but the mean of the random variable. Now the same thing apply to the random process also. Then what is the variance of the random process? Sigma square is equals to E of, in place of x I am writing here x of t whole square minus x of t bar square. That's it. So already I have calculated the mean of the Gaussian random process. No need to calculate once again. Now we calculate the mean square of the Gaussian Poisson random process. Then you can obtain the variance of the Poisson random process. So first you calculate the first term u of x square of t. So that equals to sigma k equals 0 to infinity. So what is u of x square of t? What is x of t equals to k? Then what is x square of t? Nothing but k square. So k square into what? Since it is a discrete random process, what I done here? Sigma into p of x of t equals to k. So what is p of x of t equals to k? E power minus lambda t power k by k factorial. Now I can write down this k square as k into k minus 1 plus k. How can I write k square as k into k minus 1 plus k? It means what? K square minus k plus k, nothing but k square. Therefore, I can write down k square as what? K into k minus 1 plus k. So into e power minus lambda t power k by k factorial. So instead of writing from 0, I can write down from 1, because if it is 0, I am getting 0 into something, I am getting 0 only. That's why I can replace the 0 by 1. Now, split this term. Then how write down this equation as sigma k equals 1 to n k into k minus 1 e power minus lambda t power k by k factorial plus sigma k equals 1 to infinity k into e power minus lambda t power k by k factorial. Now what is this? This is nothing but again the mean only. Previously I have calculated. What is this value? It's nothing but what? Lambda t. So you can write down this value as what? Lambda t. Now this is nothing but what? K into k minus 1 e power minus lambda t power k by k factorial. Now you can bring the e power minus lambda t to the outside. You can bring e power minus lambda t to the outside and write down this k factorial as, k into k minus 1 into k minus 2. So write down this k factorial as what? K into k minus 1 into k minus 2. So here k into k minus 1 and here k into k minus 1 will get cancelled. Then what do you get here? K minus 2 into e power, k into k minus 1, k minus 2 will get cancelled. And you can write k factorial as what? K into k minus 1 into k minus 2 factorial. This k into k minus 2 will get cancelled here. And remaining what you have here? k minus 2 factorial. So what you have here, e power minus lambda t, bring it outside, and the lambda t power k. Now, how can I write lambda t power k as lambda t power square into lambda t power k minus 2. So if you simplify, what can you get? Lambda t power 2 plus k minus nothing but lambda t power k only. So you're writing lambda t power k as lambda t power square into lambda t power k minus 2. Now this bring this lambda t whole square to the outside of this summation because it is not a function of k. Then you can write this as sigma k equals to, now I have to write down from 2 because if I write from 1, then 1 minus 2 factor is in minus 1 factor is not existing. That's why write down k value from 2. So k equals to 2 to infinity lambda t power k minus 2 by k minus 2 factorial plus lambda t. Now what is sigma k equals to 2 to infinity lambda t power k minus 2 by k minus 2 factorial. Now you expand the summation. Now if k equals to 2, substitute here 2 minus 2 by 2 minus 2. What is 2 minus 2? Nothing but 0. What is lambda t power is nothing but 1. Here 2 minus 0 factor nothing but 1. So 1 plus, if k equals to 3, lambda t by 3 minus 2 nothing but 1 factorial. If k equals to 4, lambda t of 4 minus nothing but square by 4 minus 2 nothing but 2 factorial plus and so on up to infinity. And this is nothing but what? This is like 1 plus x square by 2 factorial plus and so on infinity. This is nothing but what? E power x. And similarly in place of x I am having a lambda t. Then I can write on this as what? E power lambda t. So e power lambda t plus lambda t. So e power minus lambda t, e power minus lambda t will get cancelled. Then what I get here? Lambda t square plus lambda t. If you take common lambda t as common, then you get lambda t plus 1. So this is a mean square of the random process. Then how do you get the variance? U of x square of t minus u of x of t whole square. So what is u of x square of t? Lambda t whole square plus lambda t minus what is the mean of the random process? Poisson random process we got lambda t. So lambda t power whole square. Then what is the variance the Poisson random process is also lambda t only. Therefore, the mean of the Poisson random process is lambda t and the variance of the Poisson random process is also lambda t only. What is lambda here? The average rate, and t indicates the time interval. T indicates the time interval. And autocorrelation function of the Poisson random process. What is autocorrelation for two random variables and define the random process x of t? In the previous lecture we have seen Rx of t1 comma t2 nothing but what? Expectation of x of t1 into x of t2. Now I can write down this x of t2. I am writing x of t2 as x of t1 plus x of t2 minus x of t1. This will be cancelled. Again I am getting x of t2 only. Therefore I am replacing this x of t2 by what? X of t1 plus x of t2 minus x of t1. Now multiply these two, then what can you obtain here? U of x square of t1. U of x square of t1 plus expectation of x of t1 into, next what you are having? X of t2 minus x of t1. Now if you assume that t1 is less than t2 and assume that the random variables defined the Poisson random process are independent random variables. If they are independent, if xy are independent, then what is u of xy is equals to u of x into u of y. And what you are assuming here? You are assuming the random variables defined as Poisson random process at different intervals are independent random variables. Then what is u of x of t1 into x of t2 minus x of t1? In place of x I am having x of t1. In place of y I am having x of t2 minus x of t1. Then how can I write on this as u of x of t1 into u of x of t2 minus x of t1. Now what is u of x square of t1? Previously I have seen. So u of x square of t1. What is u of x square of t? This is. In place of t I am having here t1. What is this value? Lambda t whole square plus lambda t. In place of t I am having here t1. So write down here lambda t1 square plus lambda t1. This is nothing but the mean square of the Poisson random process. and E of x of t. What is the mean of the Poisson random process? I got as lambda into t1 into E of x of t2. So lambda into t2 in place of t, I'm having here t2. Then it is lambda t2 minus E of x of t1. In place of t, I'm having here t1. Then it is the mean of the random variable, the Poisson random variable. Define the random process at t equals t1 is given by E of x of t1, nothing but lambda into t1. If you are simplified, then what is the autocorrelation function of the Poisson random process is given by lambda square t1 t2 plus lambda into t1. And what is autocovariance of the Poisson random process? What is autocovariance of two random variables rxy minus x bar into y bar? And similar here for Poisson random variable rxs of t1 comma t2 minus x bar, nothing in place of x, I'm having x of t1. So E of x of t1 in place of y, I'm having x of t2. So E of x of t2. Then what is autocorrelation function? Previously we have written lambda square t1 t2 plus lambda t1 minus, and what is U of x of t1? The mean of the Poisson random variable at t equals to t1. So lambda t1, and it's the mean of the Poisson random process at t equals to t2, nothing but lambda into t2. So if you simplify that, the autocovariance of the Poisson random process is given by lambda into t1. And what is the correlation coefficient? Rho equals to actually what is that? Cxy by sigma x into sigma y. And similarly for the Poisson random process, what is the correlation coefficient? Cxs of t1 comma t2 by sigma x of t1 into sigma x of t2. So what is the covariance formula? This is the covariance formula. And what is here sigma x? Nothing but square root of the variance. And here also square root of the variance of the Poisson random variable. So what is the variance previously we have done? So the variance has been given by lambda into t. In place of t, if you are having t1, lambda into t1. If you want the variance of the random variable t2, then we'll get here lambda into t2. If you write down here, what do you get here? Lambda into t1 by, so what is square root of lambda into t1? So what is the variance we got? Lambda into t we got. So here square root of lambda into t1 into square root of lambda into t2. And nothing but what? t1 by square root of t1 into t2, or else you can write down this as t1 by t2 also. This is in case of t1 is less than t2. So this is a correlation coefficient of the Poisson random process. So coming to the example, an aircraft arriving at an airport accounted Poisson process at a rate of 12 per hour. How many number of aircrafts are coming at the airport? The average rate. So lambda they have given how many? 12 per hour. It means per 1 hour, averagely 12 aircrafts are arriving at the airport. And all the aircrafts are handled by one air traffic controller. If the controller takes a 2 minutes coffee break, so what is the time duration here? 2 minutes. What is the probability that he will miss one or more aircrafts, arriving aircrafts? It means how do you calculate the probability? So they have given that it is occurring, what type of process is occurring? A Poisson random process, because they are counting the number of aircrafts. Therefore, the aircrafts that are arriving at the airport are according to the Poisson random process. For the Poisson random process, what is P of x of t is equals to k is equals to what? Lambda t power k into e power minus lambda t by k factorial. So just in place of k1, what you have here? K. See here, in place of k1, here you are having what? K. So lambda t power k into e power minus lambda t by k factorial. There is a probability that the random process exactly takes k number of times. So lambda t power k into e power minus lambda t by k factorial. And here the controller is taking what? How much time of break? 2 minutes of break for the coffee break. What is the probability that he will miss one or more aircrafts? When the aircraft controller will miss aircrafts when he goes for tea break. How many times, how much time he is going for? He is going for 2 minutes of time for coffee break. So in this 2 minutes of time duration, he may miss aircrafts. Now what is a random process x of t indicates what? the number of aircrafts arriving at airport. Number of aircrafts handled by the airport. So number of aircrafts handled by the air traffic controller at the airport. That is nothing but the Poisson random process x of t has been defined. Now we have to find out the probability that he'll miss one or more aircrafts. It means how to calculate P of x of t is greater than or equals to 1. He may miss one or more number of aircrafts. So instead of finding like that, how can you calculate this as the total probability 1 minus P of x of t equals to 0. What is P of x of t equals 0? Probability that the number of aircrafts are not missing. No aircrafts are missing. Nothing but what? P of x of t equals to 0. Now, how can you write down this as 1 minus? And here, what is lambda is 12 and what is t equals to 2 minutes. This is in terms of hour, this is in terms of minutes. We change into same units, 2 by 60 hour. T equals to what? 2 minutes or 2 by 60 hour. Then what is lambda into t? 12 into 2 by 60. That equals to what? 2. So 2 by 5. So what is lambda equals to here? 2 by 5. So lambda equals to 2 by 5. Then what is the probability here? Lambda t. Nothing but what? 2 by 5 power 0 into e power minus lambda t. So e power minus 2 by 5 by k factorial. Nothing but what? 0 factorial. So that equals to what? 1 minus e power minus 2 by 5. What is 2 by 5 power 0? Is 0. 0 factorial is 1. Therefore, 1 minus e power minus 2 by 5. This is the probability that the number of aircrafts missing one or more by the air traffic control. Like that, you can find out the probability by applying the Poisson random process in the real-time applications. And one more example on the Gaussian random process. If x of t is a Gaussian random process and the autocorrelation of the Gaussian random process is 9 plus e power minus 2 into mod tau, what you have to calculate? You have to determine the covariance matrix for this random variables x of 0, 1, 2, 3. Nothing but t equals 0, t equals to 1, t equals to 2 and t equals 3. They have defined 4 random variables and the Gaussian random variables. Then what is the size of the covariance matrix? It is nothing if n is a number of random variables. What is the size of the covariance matrix? N by n. If 4 random variables are defined in the random process, then what is the size of the matrix? 4 by 4. It means how do you get? C11, C12, C13, C14. Next C21, C22, C23, C24, C31, C32, C33, C34, C41, C42, C43 and C44. Now, we already have seen that they have given that the random process is it is whatever random process is a function of only tau, is not depending upon it. So it means it is a wide sense stationary random process. And the mean is constant according to the properties of autocorrelation function. What is the property? Limit mod tau to infinity, Rx of tau is equals to what? X bar square. If the random process x of t is ergodic stationary, then limit mod tau to infinity, Rx of tau is equals to what? X bar square. Therefore, what is x bar? Nothing but what? Here the mean of the random process only. Now, if you apply tau tends to infinity, then you are getting the mean of the square. Nothing but if you want only the mean, what you have to do? You have to take what? Square root. So, limit mod tau tends to infinity Rx of tau. So, apply tau equals infinity here. Then 9 plus e power minus infinity is 9 only. So, then plus or minus cut off 9 nothing but plus or minus 3. This is the mean of the random process. It is constant, it is not varying with respect to time because it is a stationary random process. Then what is e of x of 0 is 3, e of x of 1 is 3, e of x of 2 is 3 and similarly e of x of 3 is also 3 only. Then what is the covariance matrix? We have seen the ijth element, C ij nothing but C x of ti comma x of tj, nothing but Rx of ta comma tj minus in the previous slides, we have seen that. So Rx of Ta comma minus Tj minus E of x of Ta into x of Tj. So what they are given that it is a tau is nothing but it is a difference of time. Difference of time. It is not depending upon it is depending only on the difference of the time. Therefore, I can write down this as what? Tj minus Ti. So minus E of x of Ti into E of x of Tj. So what is E of x of Ti, Tj? Whatever the value of T, the mean is constant number plus or minus 3. So plus or minus 3 whole square, nothing but one here minus 9. So Rx of Tj minus Ti minus 9. This is a covariance matrix. This is the ijth element. Now if you want C11, now what is C11? So what is Rx of tau is nothing but 9 plus e power minus 2 into mod tau. In place of tau, I'm having j minus I. So replace this by what? J minus I. Then what do you get here? 9 plus e power minus mod of j minus I into 2. So minus, here what you're having is 9. So minus 9. Okay. Now here 9 will get cancelled. Then what again here? E power minus 2 into mod of j minus I. Now if you want the first element, I equals to 1, j equals to 1. Substitute here I equals to 1 and j equals to 1. Then what can you obtain here? E power minus 2 into mod of 0. So what is e power 0 value is 1. Next second element is what? C12, I1 and j value 2. For I1 and j 2, then e power minus 2 into mod of 2 minus 1, nothing but e power minus 2. So like that you can calculate the covariance matrix for the given Gaussian random process. And thank you. In today's lecture we have seen the Gaussian random process, properties of Gaussian random process, and then you have seen the Poisson random process. For the Poisson random process we have calculated the mean, variance, autocorrelation, autocovariance, correlation coefficient. After that, we have seen some examples on the Gaussian random process as well as the Poisson random process. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.